Hello guys, welcome back. In this video, let us learn one more AWS service with a good real-time example. If you have any social media website account like Instagram or LinkedIn, then obviously the website will recommend you some connections, right? Yes. So even those connections are more relative to you. So have you ever wondered about this? How these social medias can able to provide these recommendations? So in order to provide a recommendation, first they need to store our data, right? Yes. So in which database they are storing our data, in which format they are storing, and what is the mechanism they used in between our data to provide certain relations or to recommend us any particular user. So in which format social media websites will store our data? In the form of graphs. So they store our data in the form of graphs. So they store our data in the form of graphs. Now after storing the data in the form of graphs, so graphs is the efficient way to store much more relations compared to table or key value. So that's why they store these data in the form of graphs. Okay. Now, by using which mechanism these social media websites will provide these recommendations for us? Actually, they store our data in the form of graphs, right? Now, by using which mechanism they provide these? By using advanced algorithms. What? By using advanced algorithms, they can able to find out the relationship between any two nodes in the graph. You can assume a node as a particular user data. So by using some advanced algorithms, these websites can able to find the relationship between any two new accounts, that is any two new nodes. Then they provide you the suggestion. Like this, graph stores data under nodes. So there are multiple nodes inside a graph where they are interconnected by using edges. You can assume this as relation. You can assume these as relation. If you see, let's say you opened a website that is Instagram. Now this is you and you have two friends. That is, first friend is this one and second friend is this one. Whereas these nodes represents nothing but user data. You can assume like this node maintains the user data of, let's say, Sai, and now Sai is friend to Ajay, so that's why he knows the Ajay, right? So he connected on Instagram. Now this node is maintaining Ajay data. So after connecting, they must have a relationship, right? They must have a connection, right? So that connection is established by using edges. In graph, connection is represented by using what? Edges. This edge represents what? Relationship. This node represents what? User data. Now, let's say Sai is friend to Tarun. Sai is friend to Tarun as well. So Sai connected to Tarun on Instagram. Now, this Ajay and Tarun is having a mutual friend. That is Sri Sri. So there is another mutual friend to Sai and Tarun. Mutual is nothing but common. So for both Ajay and Tarun, a mutual friend is there. The name of that friend is Sri Sri. Now you can see this Tarun and Ajay are having common friends to Sai as well as Sri Sri. So both Ajay and Tarun connected to Sai as well as Sri Sri. Now what happens is there is a recommendation system that is nothing but this graph uses an advanced algorithm that may it may possible that Sai and Sri Sri are also friends because both Ajay and Tarun having common connections, that is Sai as well as Sri Sri. Since Ajay and Tarun is having a common friend Sri Sri, there might be a chance of high probability that Sai also knows Sri Sri. So graph graph will analyze this whole relationships by using some advanced algorithms and provides a recommendation to this Sai that may Sri Sri will be one of your friend. If Sai watches that and if Sai knows Sri Sri, then he also able to connect to the Sri Sri, right? Yes. So this is how the recommendation system will work in Instagram, or else you can see in any social media. This is how they may manage your data in graph format. Whereas under graph, you can see your user data is maintained under nodes. And whatever the relations between users will be maintained by using what? Edges. So based on these relations and user data, what graph do? This graph will perform some advanced algorithms and find the relationships between other two users or any two user data and able to provide suggestions. Now let's move back to AWS. Let's say I have a social media website and I want to store such type of user data. I want to store graph related user data. Then what is the service that provides me this graph related database? What is the AWS service that provides me this graph related database? There is a AWS service called name is Neptune. What is that? Neptune, where it provides you graph related database. So, AWS Neptune will provide you which type of database? Graph related database, graph databases. It provides you services for graph related databases. It's a AWS Neptune is a graph database service. So in this database service, do I need to manage any backend infrastructure? No, you don't need to manage any backend infrastructure like EC2 instances, that is managing EC2 instances, their software like that, operating system. Those you don't need to manage. AWS will manage everything for you. So we call this service as fully managed graph database service. So what is a Neptune? It is a fully managed graph database service. Okay. It's a fully managed graph database service. So why it is used? Why it is designed? This Neptune is designed by AWS for storing highly connected data with complex relations. Why this AWS Neptune is designed? It is designed for storing highly connected data with complex relationships. In simple, you can also say this highly connected complex relationships as graph, right? So you can also say it as a graph. Highly connected complex relationships, you can call it as graph. So why Neptune is designed for? It is designed for storing graph, as well as you can able to query. So after storing your data, you can even able to query these graphs. That is nothing but highly connected data with complex relationships. Those you can able to query your data. Let's see some major use cases. You can use this database for social networking. What? Social media networking, or else you can say social media networking applications. So there it will provide you recommendations of users, and even there is a recommendation of content as well. So based on the content which a user watched, based on that related content only, the next time was updated on that user particular feed. So during that time also recommendation will provided by what? This graph database only. This Neptune also used for fraud detection. How this Neptune is used for fraud detection, sir? This Neptune is useful for fraud detection in the way, let's say there is a election movement in your area. Then it may be possible that a electing candidate will donate money for some other candidates so that to win. You can even able to identify this. You can even able to analyze the, you can even able to monitor the changes among multiple users by using this Neptune. You can able to easily identify the changes, and based on the changes you monitor, you can able to get a suggestion or recommendation that here a lot of transfer happened in between this particular node to this particular node, that is this user to this user. So there may be a possibility that a frauding of happens here. So that also will be able to identify it by using this Neptune. You can able to query. By using query only, you can able to identify these things on your database. You first need to store your data, and then you have to query your database based on related required information. So you got your required output response by using these queries. If you open e-commerce sites, so there also recommendation happens, right? So during recommendation engines, so for recommendation engines also, these are mostly used. If you open any e-commerce site like Flipkart, there you can see a recommendation happens, that is based on your previous selection of item. Now whenever a user opened the same website again, then a recommendation for particular item that he bought will be there. By you, it will be done by using this database only, that is by using the graph database only, that recommendation happens. You can do that by using this Neptune. These are majorly used scenarios. So you can use this AWS Neptune, or else you can say graph database service, based on your need wherever you require. So this is about graph and graph related database and major use cases. So in order to get some response, you first need to query your graph database, right? Yes. So let's see what are the query related services, query related things which are provided by this AWS Neptune. This AWS Neptune has its own graph database engine. So we call this as AWS Neptune Graph Database Engine, where this AWS Neptune Graph Database Engine supports the following two graph query framework. What are they? Apache Tinker, Pop, Germlin, and World Wide Web Consortium Sparkle. You can remember like Germlin and SparkQL. So these are the two query graph query frameworks that this AWS Neptune graph database engine supports. So if anybody asks you what are the graph related database frameworks that supports for AWS Neptune, then you need to answer Germlin and SparkQL. So coming to this Germlin, it allows you to query your graph, which is running in Neptune database. Whereas this SparkQL designed to work with internet and can be used to run queries against your Neptune database graph. So these two will be used like this to query your Neptune graph database. Whenever you create a Neptune, then what it will create? This Neptune will create a Neptune cluster for you. It will create a Neptune cluster for you. If you specify a single availability zone, then under the same availability zone, all your databases will be created. If you specify multi availability zone, then in that case, under multiple availability zones, your cluster will be created. So whenever you're creating a Neptune, do you need to specify your cluster name? Of course. And do you need to specify your databases need to present in single availability zone or multi availability zone? Yes. So you're creating databases, right? So for those databases, do you need to specify instance type? Yes. While configuring your Neptune, you need to configure all these things. So again, one more thing, you need to specify where these databases will be present, right? Yes. Under which VPC you want to put these databases, do you need to specify? Yes, you need to specify. So under which VPC you want to put your cluster, that you need to specify. Under which subnets you want to put this cluster, that also you need to specify. If you do not have any preference, by default a default VPC and default subnets will be selected. If you have any particular specification, then you can able to choose that as well while creating itself. You can able to provide encryption of your data as well. Even coming to database storage, so what about storage, sir? For storage, these instances storages, in addition to these instance storages, Neptune cluster also have a additional cluster storage. So in that cluster storage, you can add how many SSDs you want, those many, up to 16 terabytes you can able to add. In addition to virtual databases, in addition to virtual database clusters volumes, which contain data across all instances within the cluster, the single cluster volume can also contain a number of SSDs, where as your graph database grows, your shared volume will automatically scale and increase in size as required to a max of how much cluster storage, that is up to 16 TB only. So this is how it will be. In order to provide high availability, what this cluster will do for the volumes? This cluster will separately maintains, each cluster maintains a separate copy of shared volume in at least 3 different availability zones. So in order to provide high availability, what it will do? It will maintain a separate copy of shared volume in at least 3 availability zones. So this high availability even provides us the durability. But in order to increase the high level of durability for your data, this Neptune being provided another thing, that is Neptune storage auto repair. This storage auto repair will automatically find and detect any segment failures that are present in the SSDs. So if any segment got failed in any cluster, that got detected by using this storage auto repair, that makes up the shared volume, and then automatically repair that segment using the data from other volumes in the cluster. This ensures that data loss is minimized and the need to restore from failure in drastically reduced. To provide high durability, Neptune what introduced? Neptune auto repair. What it will do? It will automatically detects. It will automatically detect and find if there is any segment failure present in SSD shared volumes. If there are any segment failures, then this Neptune auto repair will automatically repair that segment using the data which is present in other SSD volumes. So this Neptune auto repair will reduce failovers drastically for SSD shared volumes. Similar to other databases, like if in a cluster multiple databases are there, multiple instances are there, then it classifies those into first instance as primary and other as read replicas, right? So in similar to other databases, in this Neptune cluster also, it will classify their databases in same way. That is, first database, it call it as primary database, and other it call it as read replicas, and other it call as read replicas. So this primary database is responsible for reading as well as writing. This primary database is responsible for reading as well as writing. Both reading and writing you can do under the primary database. Whereas coming to read replicas, they only provide you the read response. They only provide you the read response. So in this way, they provide you fast response for whatever the reading happens. So even they provide you low latency for your response, since they are having multiple read replicas and a primary instance, it will provide you a fast response. Basically, Neptune will distribute whatever the traffic comes to the Neptune cluster instances based on round robin method. So based on round robin method, may it distributes the traffic to primary or read replicas, and then for that, based on the read request that you provided, you got the response in very less time. That is within low latency, you got the response. It may also happen, right? That is, primary instance may fail sometimes. So if this availability zone fails, then this primary instance will also fail. So at that time, what happens? We know now this primary is failed. So can we able to write? No, it is not possible to write. So at that moment of time, what happens is your primary database, one of your read replica will be converted to primary database within few seconds. That is within just few seconds, up to 30 seconds you can assume it. So up to few seconds, your data, that means one of your another availability zone read replica instance will convert it to primary instance. It will be done by using Neptune. So in that whatever the primary instance that is created in another availability zone, there again we can able to write our data. So in this way we can able to overcome the failures which happens in any one of the region. And per cluster, for a single cluster, how many RAID replicas can I able to maintain? Per cluster, we can able to maintain up to 15 replicas. How many replicas we can able to maintain? You can able to maintain up to 15 RAID replicas per cluster. So if any primary instance got failed, then what happens in the other zone? It will promote one read replica to a primary instance. In how many seconds? It takes up to 30 seconds. So whenever your primary instance and read replica instances are created, your data is synchronized in between your primary database instance and each read replicas. So that's why these replicas even able to respond to the query. For the read request which was sent from the user to Neptune, Neptune will distribute the traffic of read request based on round robin method, and any one of the read replica or sometimes primary instance may respond to the given request. So in this way they provide the response. Whereas writing request, it only writes under the primary database. If any primary database fails, then what happens? Within 30 seconds, your Neptune will promote another read replica which is present in other availability zone to primary instance. Again, that primary instance is having both read and write permission, so that you can able to write your data, and that data is even synchronized with your read replicas. Again, you can able to read as well. So this is, in this way, this will provide you high availability, durability, and response faster with low latency. Let's say you created a Neptune database. Now, how to connect to that Neptune database? So to connect to that Neptune database, we need to have endpoints. By using the endpoints only, we can connect. Basically, these endpoints are classified into three types. That is cluster endpoints, reader endpoints, and instance endpoints. If you see about cluster endpoint, it will point to your primary database instance. It will point to primary database instance, where this endpoint will provide you both. You can able to, by using this endpoint, you can able to perform reading as well as writing. You can able to read and write. You can able to read and write by using this endpoint. So whenever you created your Neptune cluster, then what happens is this cluster endpoint will point to any one of the instance, and that will become a primary database instance. So since it is connected to primary database instance, by using that instance we can able to do both reading and writing by using this cluster endpoint. If the current primary instance got failover, then what happens is whatever the cluster endpoint that we have will just point to the another read replica within 30 seconds. Within 30 seconds, it will point to another read replica which is present in another availability zone, so that read replica will become what? Now it will become now primary database instance. Now there you can able to perform both reading as well as writing to that primary database instance. Now let's say about reader endpoint. So this reader endpoint provides a connection, that load balancing all across all your read replicas in Neptune DB cluster. So when you connect to a reader endpoint, Neptune automatically routes the connection request to one of the read replica. This can help you balance the read workloads across multiple read replicas and improve read performance. However, please note that reader endpoint does not support failure. Therefore, for write operations, you should always connect to cluster endpoint. For reader connections, you should connect to reader endpoints. So when you connect to this reader endpoint, you can only perform read on where under any one of the read replicas, because this reader endpoint points to reader replicas. So at last we have instance endpoint. Every instance in your cluster having this endpoint, that is nothing but your instance endpoint. So what are the instance may be? It may be primary instance or read replica instance. Every instance having its own cluster endpoint, its own instance endpoint, where it points to itself only. It points to that particular instance only. So when does this we allow to use? This allows you to direct certain traffic to specific instance within the cluster. If you want to traffic your if you want to provide traffic to specific instance, this allows you that within a cluster you're allowed to direct certain traffic to specific instance by using this instance endpoint. You might want to do this for load balancing reasons across your applications. For reading from your replicas, you need to load balance, right? So you can able to do this by using this instance endpoint. So these are the endpoints that you need to remember to connect to Neptune database. I hope you understood these endpoints, and I hope you understood the graph and what is the graph database, that is Neptune, that we use in AWS, and what are the advantages of it, and what are the major use cases you understood, I think, and what are the graph query frameworks that this Neptune will support, you also understood that, and how the storage will be under this Neptune managed, and how high availability and high durability is provided by using this Neptune also you understood, and how to connect to Neptune database also you understood from this video. I hope this video is contentful to you. If you feel this video is contentful to you, then please like, share, subscribe, and hit the bell icon to get the latest updates. See you back in the next video with another content. Until then, bye bye guys.